Hello, welcome to another Mr. Robertson Science Mr. Robertson video. And this one is on something I'm calling drawing an atom. We're moving into atomic chemistry. Let's start with what we do know about atoms. Now, if I talk about an atom, it's basically the smallest block that we have. So the smallest little thing that we can actually put together. So I'm made up of millions and millions and billions of atoms in my body. All the things that are our elements, they can be broken down into individual atoms. So I can have oxygen and iron and carbon. All of those elements, the Grundämne, they are made of atoms. Atoms like the smallest block. I can think of like the Lego pieces we actually have. They're the smallest things I can put together to make things that are new. Atoms, we do need to know for year 7 now about how the smallest block is actually made up. So let's go into that. And there are 3 parts to an atom. I have its proton, I have its neutron, and I have its electron. Some things you need to know about all of those is that the proton, it's going to be the positive part. This is the positive part of the atom. The neutral part is called the neutron. It's in the word. This is neutral. And the electron must be the opposite of the proton. So it is the negative part. Now you're thinking, no, an atom, it's just a thing. Why is it positive or negative? What I'm talking about here is charge. That these particles are charged. The best way to think about this for year 7? Electrons do electricity. So if they do electricity, it's the movement of these negative little things around the atom. And we can have things like static electricity. If I can rub my hair with a balloon, for example, and make the hair come up. There's an example there where I've got bits that are positive and bits that are negative. Think of it like that electric charge. So this is positively charged. This is negatively charged. So far, so good. In the atom, the proton and the neutron are in the middle. I find those inside the atom, and the middle of the atom I call a nucleus. Atomkärna. That's where I find the protons and the neutrons. The electrons, instead, they orbit outside. They go around the outside of the atom. Protons, neutrons in the middle, the electrons around the outside. Let's draw one. Let's draw one. And of course, atom number 1, element number 1 in the periodic table is hydrogen. Now, hydrogen, if I look in the periodic table, has something like this. It's got 2 numbers, and you can't see because it's too high. What this means here is that here's hydrogen, and I've got 2 numbers. They both say 1. 1 of those numbers is the atomic number, and that is the number of protons. The other number is the mass number, and this is the number of protons plus neutrons. So two different numbers there. They're both the same here for hydrogen. Hydrogen in its most simple form doesn't have a neutron. So if I was to draw this here, I start with one positive proton in the middle. I have no neutrons, because if this is 1 and this is 1, then that must be 0. But one proton is positive, so I need one electron to balance. One proton, one electron. So I do an electron on the outside, and it's in an orbit. So I would draw like that there. What's important here is that this mass number is only made from the protons and the neutrons. Electrons have almost zero mass. We can, for the time being, think of electrons as having no mass. It's actually really small, but compared to the protons and the neutrons, they are many, many, many times smaller. So the mass is only made from the protons and the neutrons. Let me take another atom. Let me go up from hydrogen to helium. And this has an atomic number of 2 and a mass number of 4. If I was drawing this one here, I would need to do some bit of maths. Just some simple maths. I need to go, okay, so the protons plus the neutrons equals 4, and the protons equals 2. Great, perfect. So I can put this answer here into that P. So I can have 2 plus n equals 4. Then I can minus 2, n, the number of neutrons equals 2. So I know for my helium, I have 2 protons, 2 neutrons, and because it's an atom, I've got 2 protons, I must have 2 electrons, like so. So let's draw this. I have 2 protons, 1, 2. I have 2 neutrons, they have no charge, they just sit in the middle. And I have 2 electrons, 1, 2, around and around, like so. That would be my helium atom. As you get bigger and bigger atoms, it gets a little more complicated. The one thing you have to know is that there's a maximum, that finns en gräns for how many electrons. So this here is what I call the first shell. And you can have a second and a third and more places for the electrons to go on the outside. What you actually have in the first shell, there's maximum 2 electrons. In the second, it goes to 8. In the third, it goes to 8. So if I had an atom which was much bigger, there would be 2 electrons in the first shell. Then it would be 1, 2, 3, 4, 5, 6, 7, 8 in the next one. 1, 2, 3, 4, 5, 6, 7, 8 in the next one. And we probably won't do anything bigger than that. If we do, I'll teach you some more. But all of the protons and the neutrons and whatever, they can go in the middle. On the outside, the electrons go. 2 in the first, then the next one, then the next one. We always start in the middle. They want to be close, then they spread out. I expect you to know what things are in the atom. I expect you to know how I can find out how many protons, neutrons, and electrons. And maybe do some drawing. Thank you very much.